Hello, grade 12. This week we continued our lesson, which is logarithmic functions. Last week we already explained how do we find the domain, how do we solve, and how do we find the limits and the derivatives. Also this week we worked on limits and derivatives, and we also started with variation of logarithmic functions. We also we defined it, and we also talked about its properties. So the properties of product, quotient, and the power. In this lecture we're going to continue. We're going to talk about the derivative of logarithmic function and limits and the graph, study variation. So first let us start with the derivative of the function. So the main rule, the derivative of len u, whatever you have inside the len, the derivative of len u is equal to the derivative of u over u itself. Okay, so the derivative of len, you will no longer have len inside the derivative. So the derivative of len u equals u prime over u. Let us take an example. Here we have the function len of x squared minus 4. Why did I put x squared minus 4 in an absolute? Because the len, you know that it's a positive function. Before starting, without doing anything, you have to take a condition. Do you still remember? We have to take condition for len. Everything inside len should be positive. And in this case we don't need it to be 0, so x is not equal to 2 or 2 minus 2. Why? Because now when I do the derivative, okay, so what's the derivative of len u? It's u prime over u. So I need to do the derivative of x squared minus 4, which is 2x, over x squared minus 4 itself. So the derivative of f equals 2x over x squared minus 4, and that's why we took the condition that x cannot be 2 or cannot be minus 2. And now the limits. Okay, those 4 rules, you have to study them very well. Len x, when x tends to plus infinity, is equal to plus infinity. So len plus infinity is plus infinity. And len when x tends to 0 plus equals minus infinity. So you know that the domain of len x is from 0 to plus infinity, which means that this is 0 plus. Okay, so I only do 2 limits, at 0 plus and at plus infinity. So limit for len x when x tends to 0 plus is minus infinity, and when len plus infinity equals plus infinity. Those 2 rules, you have to study them very well. Adding to this, limit of len x over x when x tends to plus infinity is equal to 0. You are not responsible for the calculation. You can use it, okay? You can use it as a rule. So whenever you see len x over x when x tends to plus infinity, you can directly replace it by 0. Also, when you have x len x, okay, x len x when x tends to 0 plus is equal to 0. Okay, now let us do some examples. Here we have len x over x when x tends to plus infinity. I told you that you can put it directly 0. But how? We're going to do the calculation once, but after that you are responsible for it as a rule. You can use it as a rule. Sorry for the sound, but I'm not going to repeat the video. Let us continue. So when x tends to plus infinity, that means we have len plus infinity over plus infinity. Len plus infinity is plus infinity over plus infinity. You know that infinity over infinity is an indeterminate form. In rational functions, we used to do take, for example, the highest over the highest. We used to to do factorize or rationalize, but here we can't take the highest over the highest. I don't have highest degree here. I can't factorize, and it's not radical to rationalize. So in this case, we're going to learn something new, which is called Hopital rule. Hopital rule, it comes from the word hospital. So like as if we have here a case and I need to do a surgery, urgent surgery. So what do? This is a rule. It's a rule use to help you how to solve this when you have indeterminate form in len. Hopital rule says that you have to do the derivative of the numerator over the derivative of the denominator. So it's not u over v, u prime v minus v prime u over v square. This is another one. I'm going to write it so you won't forget it. Okay, so Hopital says if you have u over v and you got indeterminate form, you can do something called u prime over v prime, which means the derivative of the numerator over the derivative of the denominator. This is called Hopital rule. Okay, so we're going to use Hopital rule, and now the derivative of len x. What's the derivative of len u? It's u prime over u. What's the derivative of x? It's 1 over x. So what's the derivative of len x? It's 1 over x. What's the derivative of x is 1. Okay, so in this case, what do we have? We do like this. Far, far, near, near. So it's 1 over x. Now, if you replace the x by plus infinity, you get 1 over infinity. What's number over infinity? It's 0. So this rule, which is Hopital rule, it helped me to find the limit whenever I have indeterminate form. Let us do another example. Here we have len of 1 plus x over x when x tends to 0. So we're going to replace the x by 0. Okay, 1 plus 0 is 1. Len 1 is 0 over 0. 0 over 0, this is an indeterminate form. So what do I use? I use Hopital rule. What does Hopital rule says? It says that you have to do the derivative of the numerator over the derivative of the numerator. What's the derivative of len u? It's u prime over u. So what's the derivative of 1 over x? It's 1 over 1 plus x. That's the derivative of the numerator. Now we have to do the derivative of the denominator. What's the derivative of x? Is 1. Okay, so I wish that Hopital rule is clear for you. So Hopital rule, applying Hopital rule, we will get 1 over 1 plus x, and now when you replace x by 0, you will get 1 as a final answer. Now we're going to study the function. How do we study the function? We do limits, derivative, table of variation, and then we construct the graph. Okay, here we have a function which is f of x. Let me highlight it. F of x equals len x. This is our function. Its domain, we know that it's from 0 to plus infinity. Okay, what's the derivative of f of x? Len u, it's u prime over u. So this is the derivative, f of x, 1 over x. You know that after derivative we study the sign, but this function is positive for every x. Why? Because x is between 0 and plus infinity, so the positive numbers. So this is positive for every x. Now we do the limit. You have to do the limit first, by the way. We're going to do two limits only, at 0 plus and plus infinity. Len 0, I told you have to study it, it's minus infinity. And len plus infinity, it's plus infinity. Okay, here we have x equal to 0, which is the y-axis, as a vertical asymptote. Now you do the table of variation. In the table of variation, as you can see, we put 0 undefined, shaded. Why? Because len 0, it's minus infinity, it's impossible, yani. It's not a specific value. So from 0 to plus infinity, it's a positive function. It's increasing from minus infinity to plus infinity. So we did the limit, we did the derivative, we did the table of variation, and now we have to plot the graph. Look at the graph. I'm going to put everything in front of me. The only thing that we know is that the y-axis is an asymptote, right? It's a vertical asymptote. In order to construct this curve, we need to take some particular points, okay? In these points, I'm going to choose x and f of x. I'm going to choose, of course, I'm not going to choose 0 because len 0 is minus infinity. I'm going to choose 1 and e, okay? Len 1, if you replace x by 1, len 1 is 0. Len e is 1. Those are the easiest points. Let us put them on the curve. This is 1, 0. So this is the first point, 1, 0. Now the second point, which is E1. You know that E, it's 2.7. We already discussed this. So 2.7, almost here. So this is 2.71, and now we construct the curve. You know that it's coming from minus infinity till plus infinity. So this is an asymptote. It should pass through those 2 points, and it's increasing. So kind of, okay, this is the curve. It comes beside the y-axis. It passes through those 2 points, and it continue increasing function. That's everything in this lecture. So we learned about the derivative, the limits, and how we study variation. Okay, I wish that you solve the worksheet, because it's very important, because this time we're going to do a complete question, a function question about len. Okay.